What time is it on the moon? Well, soon we might actually be able to answer that because the US has asked NASA to establish a unified standard of time for the moon. People might be wondering why the time on the moon isn't just the same as the time on Earth. In our everyday lives, time ticks by normally, but Einstein's law of general relativity tells us that time isn't absolute. It changes depending on where you are in the universe. The rate at which clocks tick depends on the gravity of your location. One of the most intriguing aspects of our universe is the complexity and peculiarity of time. Although it seems like a constant that governs the rhythm of our lives, time's behavior is not as straightforward as it may appear. The flow of time itself is influenced by various factors, including gravity and motion, as famously revealed by Albert Einstein's theories of relativity. For example, time passes ever so slightly faster at the top of a mountain compared to the valleys of Earth. This phenomenon, which may seem trivial on Earth, becomes far more significant as humanity extends its reach beyond our planet, particularly in the context of lunar exploration. The renewed space race, marked by efforts to establish permanent settlements on the moon, has brought this issue to the forefront. As nations like the United States, China, and their allies prepare for future lunar missions, scientists are grappling with a critical problem: how to keep accurate time on the moon, where the seconds tick ever so slightly faster than they do on Earth. Before diving into the intricacies of lunar timekeeping, it's essential to understand how time is measured on Earth. For millennia, humanity relied on natural systems like sundials and the phases of the moon to track the passage of time. While these methods were sufficient for ancient civilizations, the rise of mechanical clocks in the 14th century, followed by the advent of more advanced timekeeping systems, made it clear that a higher level of precision was needed. By the 20th century, timekeeping had become an exacting science, especially after Einstein's theory of relativity. Einstein introduced the concept that gravity can affect the passage of time, meaning that the closer a clock is to a massive object like Earth, the slower time will pass for it compared to a clock farther away. As a result, clocks on the surface of the Earth tick at a different rate than clocks in orbit. In the modern world, time is measured with incredible precision using atomic clocks. These devices rely on the vibrations of atoms to track the passage of time with extreme accuracy. Atomic clocks are now used worldwide, and their readings are averaged to produce Coordinated Universal Time, UTC, the global standard for timekeeping. However, the increasing reliance on precision time measurement for everything from navigation and communication to financial transactions has made it clear that even slight variations in the passage of time must be accounted for, with occasional leap seconds added to keep UTC in sync with the Earth's irregular rotation. Now, as humanity looks toward returning to the moon, the complexities of timekeeping have become even more pronounced. Unlike Earth, where time is measured in accordance with the planet's rotation and gravitational pull, the moon's own characteristics introduce additional complications. One of the most significant issues is that a single Earth day would be about 56 microseconds shorter on the lunar surface. While this may seem like a tiny difference, over time, such discrepancies can add up, causing significant inaccuracies in long-term operations like navigation and communication with spacecraft. To ensure that astronauts on the moon can maintain accurate schedules, communicate effectively, and navigate the lunar surface, it is crucial to account for these subtle variations in time. NASA and its international partners, including the European Space Agency, ESA, and other spacefaring nations, are working together to solve the lunar timekeeping puzzle. The challenge is not just to create a lunar time zone, as some might assume, but rather to develop an entirely new timescale, a system of measurement that reflects the peculiarities of time on the moon. This new timescale will allow for accurate synchronization of activities on the lunar surface and ensure that astronauts can operate within a reliable framework for time. According to Cheryl Gramling, the lunar position, navigation, and timing expert at NASA's Goddard Space Flight Center, the goal is not simply to establish a new time zone, but to create a time system that considers the faster ticking of seconds on the moon. Gramling's team is working with international partners to devise a time system that space agencies can agree on and implement as part of their lunar missions. A recent memo from the White House has directed NASA to outline a plan for this new timescale by December 31, 2025, and to implement it by 2026, the same year the U.S. aims to return astronauts to the moon for the first time in 5 decades. This time system will be crucial for ensuring that future lunar missions can operate smoothly, from astronaut navigation on the surface to communication with Earth-based mission control. To address the timekeeping challenges on the Moon, scientists must deploy highly precise clocks to the lunar surface. However, the Moon's environment presents additional challenges that will require different strategies than those used on Earth. While atomic clocks are well-suited for long-term stability, they are expensive and may not be practical for all lunar missions. Instead, scientists are exploring the use of different types of clocks, including crystal oscillators, which offer good short-term stability at a lower cost. However, there are trade-offs involved. Crystal oscillators, while cheaper, may be less accurate over time, and their potential to drift by milliseconds or more could create serious problems for navigation. For precision operations such as spacecraft navigation and communication, clocks must be synchronized to within tens of nanoseconds, a level of accuracy that requires top-tier equipment. To achieve this level of precision, scientists plan to deploy a variety of clocks, possibly embedded in satellites orbiting the Moon or placed at specific locations on the lunar surface. By using a network of different clocks, each contributing to the overall timekeeping system, scientists hope to create a lunar timescale that is accurate enough to support complex lunar missions. The creation of a new lunar timescale is not just a technical challenge but also a diplomatic one. As space exploration becomes an increasingly international effort, coordination between different space agencies and nations is crucial. This is especially true as NASA and its partners prepare to establish Lunar, a network that will connect lunar activities and ensure they are coordinated in real time. Lunar can be likened to an advanced version of the Internet, combined with a global navigation satellite system. It will serve as the backbone for lunar communications, navigation, and timekeeping, and it will require international cooperation to ensure that all contributors to the network adhere to a shared set of standards. The success of Lunar and the new lunar timescale it will support will depend on the ability of spacefaring nations to work together toward a common goal. However, it remains to be seen whether countries like China, which are not part of the Western Space Alliance, will be on board with this new timekeeping framework. The discussion surrounding this issue will likely take place through international standard-setting bodies like the International Astronomical Union, but it will be critical for NASA and its partners to navigate these diplomatic challenges as they develop the system. For astronauts on the Moon, the implications of lunar timekeeping go far beyond the technical. Time on the Moon operates according to a completely different rhythm compared to Earth. The Moon's unique orbital mechanics mean that one lunar day is equivalent to roughly 29.5 Earth days, 14 days of continuous daylight followed by 14 days of darkness. This long cycle of light and darkness will create new challenges for astronauts in terms of their daily routines and their ability to coordinate activities. Additionally, astronauts working on the lunar surface will need to synchronize their efforts with one another, often in real time, while managing the complexities of living in an environment with extreme temperature variations and isolation. The ability to rely on precise timekeeping will be vital for everything from scientific experiments to lunar navigation. Time, for example, will be essential for ensuring that astronauts stay on schedule when they conduct experiments, explore the surface, or interact with robotic systems. However, Gramling notes that the new lunar timescale could provide an opportunity to rethink how humans experience time altogether. The Moon's unusual day-night cycle, with its 14-day stretches of sunlight and darkness, presents a unique opportunity for astronauts to establish new routines and schedules tailored to the Moon's environment. These schedules may be fundamentally different from anything experienced on Earth, but they will be guided by a reliable and precise system of timekeeping that helps ensure mission success. While timekeeping on the Moon is undoubtedly a critical task in the short term, it also holds long-term implications for the future of space exploration. If scientists can establish a reliable and accurate timescale for lunar missions, they will have laid the groundwork for similar systems on other celestial bodies, such as Mars, asteroids, and beyond. For example, NASA's long-term goal of sending astronauts to Mars will require a timekeeping system that accounts for the unique characteristics of the Martian day and its relationship to Earth time. If the system developed for the Moon works as planned, it will provide valuable lessons and technologies that can be applied to other missions in the future. The quest for accurate timekeeping on the Moon is not just a scientific challenge. It is an opportunity to advance human understanding of time and its relationship to the universe. As humanity prepares for a new chapter in lunar exploration, the development of a precise lunar timescale will be foundational to the success of future missions. By collaborating internationally and leveraging the lessons learned from Earth-based timekeeping systems, NASA and its partners are working to create a new system that will allow humanity to navigate, communicate, and operate on the Moon with unprecedented precision. This endeavor not only marks a crucial step in the exploration of our closest celestial neighbor, but also paves the way for deeper, more ambitious missions into the cosmos. In a universe governed by the laws of relativity, the ability to measure time accurately, whether on Earth, the Moon, or beyond, will remain one of the most important tools in humanity's quest to explore the stars. As humanity continues to advance in space exploration, the issue of timekeeping on the Moon is not merely an academic curiosity. It is a practical necessity that will play a key role in ensuring mission success. For example, accurate timekeeping is crucial for coordinating the various activities of astronauts on the lunar surface, ranging from scientific research to the operation of lunar rovers and the maintenance of habitats. Each of these tasks will require precise synchronization with mission control on Earth, and even small errors in time could lead to serious complications. The creation of a lunar timescale that aligns with the Moon's unique environment will allow astronauts and mission planners to better manage the demands of long-term lunar missions. Moreover, the need for a unified timekeeping system on the Moon extends beyond just the direct operations of lunar missions. As various nations and private companies increasingly focus on space exploration, the coordination of activities between different parties becomes more complex. To avoid conflicts and ensure smooth operations on the Moon, it is imperative that all parties involved in lunar exploration adhere to the same timekeeping standards. This is particularly important as commercial entities, like SpaceX and Blue Origin, enter the space race with plans for lunar tourism, resource extraction, and scientific collaborations. A common timescale will facilitate the integration of these diverse activities, helping to streamline communication and prevent misunderstandings. In addition to this, lunar timekeeping is essential for the long-term sustainability of human presence on the Moon. As plans for lunar bases evolve, time synchronization will be crucial for managing everything from the movement of supplies to the upkeep of equipment and systems vital for survival. The Moon's 29.5-day cycle, with extended periods of sunlight and darkness, will make it necessary for astronauts to develop new routines that take advantage of the unique characteristics of the lunar environment. These schedules will likely differ greatly from those on Earth, and having a reliable time system will enable astronauts to optimize their daily activities while maintaining the health and functionality of their habitats. Another factor that makes timekeeping on the Moon challenging is the lack of a natural environment similar to Earth's, where the Earth's rotation provides a familiar and consistent rhythm for time measurement. The Moon's lack of atmosphere, the extreme temperature fluctuations, and its low gravity all present obstacles to traditional timekeeping methods. For instance, the way time is currently measured through the oscillation of atoms in atomic clocks might be affected by the Moon's temperature extremes, potentially causing minor fluctuations in readings. As such, new methods of keeping time will need to account for these lunar-specific challenges, which will involve innovative technological solutions. Timekeeping on the Moon also has the potential to serve as a stepping stone for future space missions to other planets, such as Mars. The Martian day, or Sol, is approximately 24 hours and 39 minutes long, which creates its own set of challenges for developing a time system that integrates smoothly with Earth-based schedules. By establishing an effective lunar time system, space agencies can test and refine timekeeping technologies that could one day be applied to other celestial bodies with different time cycles, helping to create the groundwork for human missions to Mars and beyond. In addition, the success of lunar timekeeping could have broader implications for future space exploration beyond the technical aspects of space missions. The establishment of a global, unified time standard for the Moon could serve as a model for international cooperation in space exploration. As countries around the world recognize the shared interests in exploring and utilizing space, the ability to work together harmoniously will become more important than ever. A successful collaboration in lunar timekeeping could demonstrate the benefits of international partnerships and provide the foundation for future joint missions to other planets, asteroids, and even beyond the solar system. Furthermore, The long-term use of the moon as a base for scientific research, resource extraction, and technological development could create the need for entirely new systems of time management. This is particularly true as humanity moves toward establishing a permanent presence on the lunar surface. With the lunar environment being so different from Earth's, astronauts and mission planners will need to rethink many aspects of timekeeping, including how to synchronize the biological rhythms of astronauts with their operational tasks and objectives. A reliable and accurate time system will be essential for ensuring that astronauts maintain good health while staying productive, as even minor disruptions in sleep schedules or daily routines can have a significant impact on their performance. In conclusion, the task of establishing a precise lunar timescale may seem daunting, but it is a crucial step in the broader context of space exploration. As space agencies and international partners continue to collaborate on lunar missions, the need for a unified time system will become increasingly important. Not only will it ensure the smooth coordination of activities on the moon, but it will also lay the foundation for future exploration efforts on other planets and in deeper space. By solving the problem of lunar timekeeping, humanity will not only advance its technological capabilities, but will also demonstrate the power of global cooperation in the pursuit of common goals. The future of space exploration is an exciting and unprecedented chapter, and accurate timekeeping will be an essential tool in helping us navigate the vastness of the cosmos.